Today we are going to look at how to model tapered plates. We'll be using cone root plates for that, and the drawing we are going to use is this particular drawing. I will put it in Dropbox, and one thing I would like you to do is study the drawing. There are some inconsistencies here. I would like you to find out those inconsistencies and raise questions. For this training purpose, I am going to go in a certain way. That may be not correct, but my purpose right now is to show how to model a tapered plate. I am going to use this drawing. There are problems with drawings. I want you to identify the problems and tell me what is wrong with the drawing and also what I am doing wrong here. This drawing shows a dimension A and a dimension B on a certain view, and we have a section view here, and then we have another dimension here which says 32. I want you to make sense of all this and then come up with a model and a drawing. If you can't make sense out of this, then you must ask questions which are relevant. Now we are going to model these two plates. So the dimensions of these two plates are given here. We are only going to model this. I am going to give you this Excel sheet. I am going to delete most of the data and give you only a few. Now, okay, if you look at this particular plate, dimension A is 470, dimension B 570, and if you look at the drawing, you should understand what is T1, T2, T3, T4, etc. And the maximum thickness out of that is 32. And if you look at this one, the maximum thickness out of that is 35. We can buy a 32 plate, so I am using for this particular item the 32 plate. For this one, you can't buy a 35 plate. The next higher size is 36. So what we will be doing is we will buy a 36 plate and then machine it down. Machine it down maybe like that. So we will be machining away this portion. I have already set up some grid to match with the dimensions we require, so which is 470 by 570. The first plate we require is a 32 millimeter plate. I press shift and click the button here to bring up the properties, and I am going to change the plate thickness to 32. And I want the plate to come up, so I'm going to change that to front. Now to model the plate, I am going to click 4 points, 1, 2, 3, 4, and then middle button. So I should get the plate and it should be at the front. So you can see that is at the front. Now if you inspect the Excel table, the thickness at T1 is going to be 20 millimeters. We started with a 32 millimeter plate. So from that 32 corner, we have to take off 12. So the corners are labeled here as T1, T2, T3, T4. So I am going to take off 12 millimeters away from this corner. For that, first I select the plate, then I press the Alt key down and then draw a window over this handle. And it brings up the properties of that particular handle, and it says type sharp, and D is at 1, 0, D is at 2, 0. So I'm going to put D is at 1 is equal to minus 12 and then modify. So you can see that this corner has gone down. This corner has now gone down. Let's check the dimension. So I use the measure tool, and that's 20 millimeters. For T2, I have to take off 6. Again, I press the Alt key and draw a rectangle over that, and that corner properties come down up here, and then I go minus 6, modify, measure, and that's 26. I do the same thing for T3 and T4. T3 has nothing to be taken off, so nothing to be done. T4 I have to take off 6. You may note that I have modified these two corners, and then now if I click on that, you can see this face is not planar anymore. So if I probably modify this one, it may become planar. Let's try that one. And -6. Okay, now they are all in one plane. So that's as much as the modeling is concerned. Now let me copy this into the name field of the model. Modify. Now we are going to just enter into drawing area a little bit. We will cover drawings exhaustively in further lessons, but we are just going to have a small taste of this. I'm going to make an inquiry on this part, and let's look at the part position number. See, it says P/0 and a question mark. Assembly position also P/0 with a question mark. So that means this part is not numbered. So if you inspect the numbering series, you can see the part numbering prefix is P, assembly numbering prefix is P, and the start number is 1, and start number is 1 for assembly as well. We'll keep it like that and do a numbering. We go there and then click perform numbering modified object. Now if you inquire the part, you can see it has got a number. No question mark has disappeared. It has got part position number P1 and assembly position number P1. Now let us change the prefix of this one. The part position number we are going to change to M, and assembly position number prefix we are going to change as PLT. PLT, capital letter, and modify. Now if you inquire the part position, you can see a question mark. The prefix has changed to M and the assembly prefix has changed to PLT, but there's no number. It comes with a question mark because we have changed the prefix. It requires renumbering. So let's renumber the modified parts, modify the objects. So let's re-inquire again the object, and you can see that part position is now M1 and the assembly position is PLT1. You can experiment with that. There's a fair bit into numbering, and Tekla is actually very good in numbering. So you have a play with this at the moment. We will cover numbering in great detail later. Now if you have to create drawings, first you have to number. That is a must. You cannot create drawings without numbering. So we are already numbered, so we can now go and create drawings for this. We are going to create a single part drawing. So select that part, right click, and then create single part drawing. Creating drawing finished. One drawing created successfully. We can also create assembly drawing. So go create drawings, assembly drawings. Now to look at the drawing list, you press the Control key and then L. So you can see the drawings here. Let's open the drawing. Let's look at M1. That's the drawing. It has created a drawing 570 by 470, and it has put some dimensions here. And if you look at the bill of material, it tells the plate thickness is 32 and the length 470, width 570, mark is M1, weight is 54.68. That's the part drawing. Now let us look at the assembly drawing. It will be the same here. Again Control and L. So PLT. Here you can see one mark PLT1 required, and this is the name we have put it in the properties of the object. If you look at the drawing name of the part, it comes up with M1 here. The assembly would be PLT. You can insert DWG files into Tekla drawings by the drawing link. See, I have created this drawing in AutoCAD, and then I can use the DWG-DXF link to bring that in. So what you do is you click that button, browse to the drawing. So that is the drawing which I created, and I can insert that. So you say apply OK and then click the position. You will have to modify the scales to suit the scale of your drawing, and you can insert it. In this case, because there are so many plates and these holes are all the same for all the plates, which is 32 millimeters from the edge, and the center distance is the same as well, so it may be beneficial for, in this particular case, to create a DWG drawing and plonk it on every drawing. We can bring it into every drawing. When we use the clone option, it will automatically come. You can try that out.